All right, so I wanted to look at an inequality where this was not always 0. So the problem is we need to get it to be 0. So I am going to go ahead and factor this a little bit just to kind of see what that is. All right. And so I'm going to bring that -3 over. So, and when I subtract it from both sides, obviously I get 0. Now, I am going to multiply it by the common denominator, which is x plus 2 quantity squared, because unfortunately we have to do fractions here. So I'm going to make one big fraction bar. So my first one is fine. And I know what this is multiplied out from the original, but otherwise just multiply it out again, not a big deal. And just make sure you distribute the negative with it to all three. And all of this is over my common denominator. All right, those equal 0. I get what? X minus 3. Right there. And again, if you had a graphing calculator, you could just have this be y1, y2, and you could kind of look at that graph to see. But if you didn't have a graphing calculator and you wanted to graph this, you could do that as well. So you could do, you know, kind of an asymptote over here, what, -2 and 0. This one you got to be a little careful. You could sub in, say, like a -3, and you get what, a -6, and you could kind of, you know, graph it over here. And notice if you get really big negative numbers, as x gets really, really absolute value or magnitude negative, when you square it, that's going to be positive, but on top you're still going to get negative. So you're not going to ever have to worry about the output over here being positive. This output over here is always going to be negative. You have to be a little careful over here. You could sub in, you know, a point on this side. Where am I at? There's my 0. And this one's going to, you know, kind of go with this asymptote too, and they're going to both be together because of our multiplicity. But remember, horizontal asymptotes are kind of suggestions. And so you got a little be just a tad careful. If I set this equal to 0, like an equation, and multiply both sides by the denominator, so I'm going to clear that. Those cancel. I get x minus 3 equals 0. Add 3 to both sides, x equals 3. So over here, this is going to cross 1, 2, 3. So there's going to be an x-intercept there. And then, again, if you put a really big positive number in size-wise, you're going to get a positive over a positive, and so this is going to go over here. Now, again, you know, with asymptotes, yes, there is, if you look at the original, there is, let's see, the original has one at 3. What about our new one here? Our new one has one at, what, x over x squared, so the limit as x goes to infinity, right? This one would have one at 0. But, again, remember, horizontal asymptotes are kind of a suggestion sometimes. It's an asymptote for somebody. It doesn't mean it's an asymptote for everybody. So this horizontal asymptote in our new kind of revised function is for this part of it. That asymptote is not for this guy. Okay, and that happens sometimes. These two do have to be together because of multiplicity, though. So I do know kind of their behavior because of multiplicity, and it hasn't been reflected. But other than that, this asymptote applies to this guy. This asymptote does not apply to that guy. So again, I could use my graph and say, okay, so when is my graph, this guy right here, less than 0? And so I can look and I could be, okay, well, you know, it's less than 0 here, and it's less than 0 there. And so I could write my answer and say, all right, I can visually see this -infinity to -2. And then we're going to pick up on the other side of -2, and we're going to go to, what, 3? And bracket, because at that point I want to know when it's either negative or less than 0, and at that point it's going to start being positive over here, output, so I don't want that. But again, what if you don't want to graph? Because that's the whole point. Either graphing calculators don't exist, which would have been my high school experience, or you don't have one, or you just don't even want to mess with it, or your teacher forbids you from using one. So all those are kind of some options here. So if that's the case, what you can do is you can just make a handy-duty little number line and put your key points on it. So -2 is one part of the graph that's important, and then the other part was earlier when we solved for that x-intercept at 3, and that was important. This one we can equal because, you know, equaling 0 is great. This one, even though we can equal, the problem is that's undefined, so that's a problem because of that. And so again, you can just test points in kind of these key areas. So if I sub in a -3 for my x value, let's see, then what do I get? -6 over 1. So yeah, so my output is -6. So since my output's negative, then that's good because I want negative. And then I could pick a number in between here, which, you know, 0 is kind of a nice, easy number. I get what? -3 over 4. That's negative. And again, that appears to be good because of this guy. And then I can pick a value over here. So heck, might as well pick, say, 4. Shove it in there, and what do I get? I get 1 over 36, which is positive, all right? But notice, again, I am asking myself, when is the output negative, all right? So without really even knowing what the graph looks like, I know that the output is negative for that key point and negative there, including that key point, and then the rest of it doesn't apply. So what's my final answer? So if I start over here on the number line, right? So start here at -infinity. So from -infinity, I have an answer all the way till I hit -2, not included because obviously that would be undefined. And then I pick up my answers again. So union, pick them up at a -2, and then go all the way to 3. And again, that's included. So, you know, if you want to get the answers without graphing, and you don't have a graphing calculator or you're not allowed to use it, then what you're going to want to do is look for vertical asymptotes that are going to block the x-axis or values on the x-axis, and then look for x-intercepts where obviously your graph is going to cross the x-axis. And then, you know, just kind of see what's going on at all those points. And you can always add extra if you're paranoid. But otherwise, that's all you need to check. And there's your answer.